right, let's get started. Thank you all for joining this session. So what I'm going to cover today, I'm going to be talking about 3 items. First one is that I'm going to give a quick introduction into Azure Site Recovery. If you haven't used or heard about Azure Site Recovery before. And then what I will be doing is specifically going to talk about VMware workloads, how you can migrate into Azure. And the third capability that I'm going to cover off today is Azure to Azure DR, or how you protect your workloads that you've migrated up to Azure using a preview capability that we have part of Azure Site Recovery. My name is Nirmal Tevaratantri, so I'm from Western Australia, based in Perth. Work as a technical architect for Empire. I'm also a Microsoft MVP for the cloud and data center management category. So what I will be talking, as I mentioned before, covering the 3 areas. And also we will be going into a demonstration where we will move some of the workloads from an on-premises environment into Azure. And also we will look at, once these VMs are running in Azure, how you can protect those virtual machines. So if you look at Azure Site Recovery as a solution, Azure Site Recovery allows you to do disaster recovery and coordination. Whether you have on-premises, 2 data centers on-premises, you can utilize Azure Site Recovery to protect them, to orchestrate your disaster recovery. Azure Site Recovery also has the capability to act as a disaster recovery toolset or a migration toolset from an on-premises environment into Azure as well. Also, we support for migrating, if you have workloads running in AWS, as an example, you can utilize Azure Site Recovery to migrate your AWS workloads into Azure as well. And one of the preview capabilities, as I mentioned before, we can also protect workloads between 2 Azure regions. So if I have some workloads running in Sydney data center, I can protect them into the Melbourne data center. So that's a preview capability, which I'm excited to demonstrate that today. So where does it stand with the other vendors and the solutions available in the market? So this is a quick snapshot from last year's Gartner's Magic Quadrant for disaster recovery as a service. So if you look at Gartner, they've rated the Microsoft Azure Site Recovery service as a leader, both from a visionary as well as from an execution. And looking at a lot of the features that's been added past 6 months, past year, and also looking at the capabilities that are upcoming part of the tool set, they've placed Microsoft as the leader in the disaster recovery as a service Magic Quadrant. So one of the questions that I get frequently asked when we have conversations around migrating workloads or having disaster recovery is, what are the supported applications, or what applications are supported? So if you look at today, Azure Site Recovery is the only solution which is supported and backed by Microsoft, which you can use to migrate workloads into Azure, as well as protect your workloads in a disaster scenario. Supportability also extends not just for Microsoft, but also extends with other vendors as well, such as SAP, Oracle, and also with Citrix as well. So there are multiple vendors, multiple applications that are supported, not just the Microsoft portfolio. So when we talk about migrating into Azure, so in this specific example, I will look at how you can migrate your VMware workloads up into Azure. There are 4 phases that we need to ideally walk through, 4 phases that we need to look at. The first phase is around the planning. So when I talk about planning, there are 2 parts into planning. The first one is that you need to first plan for your Azure environment. Number of subscriptions that you create, creating an Azure Recovery Vault. These are the things that you need to plan for from an Azure perspective. Have governance set up for your Azure subscriptions. So that is what you would plan from an Azure end. And also, you need to plan for your on-premises environment as well for you to be able to do a successful migration from your on-premises environment up into Azure. So once you've done your planning, network assessments, once you've done that, the next step for you would be to start replicating your virtual machines into Azure. So once you've started replicating, let's say we use 10 virtuals per batch. So let's say I have 80 virtual machines, so I would do 8 batches. I start replicating across into Azure. So at one point, when the data gets replicated into Azure, the virtual machines will become protected state, in which case you have 2 options. One option is that you can migrate and you can cut off. Or another option is that you actually can do a test failover. Why is this important? Having done multiple migration projects for a number of customers, some of the applications, because they are not tested to run in Azure, especially custom developed applications, especially legacy versions of applications, having used Azure Site Recovery gives us the flexibility to do a test failover in an isolated environment, again, not impacting your production environment. We can do the testing on an isolated environment to be able to know whether the application will work when you actually do your DR failover or when you actually do your migration. So that's an important capability that's available, and it's something that needs to be looked at when you are migrating your production workloads up into Azure. So once you've done your testing, you've confirmed that the application works up in Azure, then the last phase is that this is where you would cut over. So when you do the cutover, your applications will shut down on your on-premises environment, and they will then run in an Azure environment, in the Azure data center that you select. So for us to start looking at the migration strategy, Azure Site Recovery, as I mentioned before, allows us to migrate workloads from not just Hyper-V, but across multiple different vendors as well. So we have supportability for VMware. We have supportability for AWS. We also have supportability to migrate from physical assets as well. We can migrate both Windows workloads as well as Linux workloads. So it's not, again, something that is restricted to Windows workloads. We can do both Windows as well as Linux. And also, what I mentioned before, it allows you to do a no-impact test before you actually do a cutover, because maybe you do the cutover and you notice that the application doesn't work. So at that point, it could be a bit too late for you to either do a failback or whether to discard the copy that you have up in Azure and start to run your production environment. So it allows us to do that no-impact testing in an isolated environment without impacting what's running in the production environment. Also, the replication we do for our virtual machines, this is an online replication, so it's not an offline replication, which means that we can achieve near zero downtime for our migrations. So when we have migrated replication, when we have started our replication, at a point you would see that it comes back with protected state, which means that the data is in sync with Azure. And based on the RPO and the RTOs that we select, it would, in intervals, it will then start moving any data changes, it will start shipping that across to Azure as well. So at a given point in time, even if you do a cutover, you would, at a maximum, you would lose about 15 minutes of data if you do a cutover. So it's really a near zero downtime that we have, part of the tool set. Also, specifically for migration scenarios, Microsoft provides 31 days free for Azure Site Recovery. So if you are doing a migration per virtual machine, you get 31 days free. So that allows you the opportunity for you to be able to do the migration, do your testing, and then finally do a cutover. And the last capability that I will talk about, which is the hybrid use benefit, again, an add-on that we had a few months back, which was added for Azure Site Recovery. With the hybrid use benefit, customers moving their on-premises workload into Azure, if they're having an enterprise agreement or have software assurance, they can move those licenses into Azure. So what's the benefit? The benefit is that you would get up to a 40% reduction in cost, because now you are only paying for the compute cost of your virtual machines in Azure. You are not paying for the compute cost and on top of it, the Windows Server license. You're only going to pay for the compute cost. So if you look at the hybrid use benefit, you would get up to a 40% cost benefit when you leverage your on-premises licenses up in Azure. So we've kind of done a bit of an overview around Azure Site Recovery. So what I'm going to do next is I'm going to dive a bit deeper into the VMware scenario. How, if you are running VMware workloads at the moment, how you can protect those workloads or how you can start migrating those workloads. So we've also looked at what are the preparation we need to do in Azure. So we've done our subscriptions. We have a governance model up in Azure. We've created a recovery vault. So what do we do next? So next, what we would be doing is we would set up a management server in our VMware environment. The management server combines a configuration server, combines a master target server and a process server, which is vital for Azure Site Recovery to work. And then what we also need to do is we have an agent that we need to deploy onto your virtual machines. Now, why do we need to deploy an agent? We're already doing this replication at the hypervisor level, but why is this required? The reason behind putting the agent into the virtual machine is to understand what is actually in memory. So any of the read writes that is in memory, we can use those read writes and we can make sure that there is application consistency when we move your workloads up into Azure. So you can restore to a different recovery point. Let's say the last replica that you had has a corruption. You actually can go back to a previous recovery point, and you can restore from that recovery point. So we need to also have the mobility agent, mobility service agent deployed onto your virtual machines as well. And once you've done that, you can then do your testing, and you can then migrate that workload across to Azure. So let's look at how does it work? What are the internals that we have? So when you really look at it, in your VMware environment, we talked about having that management server. We have the three components. So the configuration server does all of the coordination. The process server does all of the compression, the encryption that is required for the data to be shipped to Azure. And the master target is used in scenarios where you need to do a failback. So when you want to do a failback, that happens through the master target server. And also, if you look at in here in this diagram, the process server actually ships all of that data into a blob storage. So what is the benefit? The benefit is that you don't need to run two virtual machines, one on premises, one in Azure. So you don't have to pay for those virtual machines running. All you're doing is you're doing a data replication. So if you are a customer, if you don't have a DR solution, you can essentially take advantage of this, and you can have Azure as a standby data center, as a standby site, without actually paying for any of the virtual machines running. So having that data replicated into a blob storage, at a later stage, let's say I want to do my test failovers, or I want to do my migration, Azure Site Recovery will orchestrate the virtual disks that are being copied across and create virtual machines for you automatically. So that's how the coordination process works. So what I will do now, I'm going to go into a quick demonstration and show, before we start migrating workloads into Azure, one of the first things that we need to do is we need to start protecting virtual machines. We need to start adding those virtual machines so that the virtual machines can get replicated. So I'm just going to go into a quick demonstration. First, I'll show you my environment that I've set up. So I've got a VMware environment in Perth, which is connected to Azure Melbourne Data Center as well as Sydney Data Center. So if you look at in here, what I have is few virtual machines running in ESX version 6, managed by vCenter. And then what I also have in here is a process server which I've configured. And in Azure, what I have here is multiple recovery vaults which I've created for different purposes. So we will look at what each of the ones are for. But the one that I want to show in particular is the VMware Recovery Vault. So if I go into the vault, one of the things that I want to show you is that the on-premises connectivity that we've created. So if I go into site recovery infrastructure, and if I go into configuration servers, this would show me my configuration servers, my process servers that I've added. So as one of the first steps that you need to do, you need to be able to add your management server. So if you don't have a management server, once you've created all of your resources in Azure, once you've created them, once you've created the recovery vault, this would be a first step for you to go into the vault, and then what you would do is you would say add server, which gives you detailed instructions in here. Essentially gives you access to the binaries for you to go in and install the setup files. And also there's a vault key that allows secure communication from your configuration server, from your management server up into the Azure vault. What I've also done, if you look at this particular configuration server, I've also added multiple process servers. So we will talk about why we need to do this and in which scenarios we need to do it. So if you want to scale your environment, if you have multiple workloads, you can essentially scale out. So you can add number of process servers into the environment, number of master target servers. So if I expand this further, you would also notice that I have multiple master target servers as well. So we will look at in detail why we need some of these services. But before moving ahead, what I want to do is I want to quickly go in and add few VMs under protection, so the replication process will work. So I'm just going to go and click replicate. So one of the important items in here is that first thing is that I need to select the source. So at the moment, because my Azure subscription is whitelisted for Azure to Azure Preview, I have this option which says I can select whether it's Azure and on-premises. But in your subscription, if you look at today, you might not have the Azure option. So I've selected my on-premises environment, that is the source. I'm also going to select my configuration server. So if you see in here, I can also coexist Hyper-V environment and a VMware environment as well. So let's say for dev test purposes, I have a Hyper-V environment. I can also connect that Hyper-V environment up into my Azure Site Recovery Vault. So what you're looking at right now is really coexistence between the two hypervisors. So I've selected my VMware process server. I will also select my vCenter server. And then I can select, based on the workload that you are moving across or the number of batches, you can select different process servers for you to migrate that data across. So I've selected all of that. Next, what I will be doing is I'm going to select the target machine. So how do we get the information around target machines? In here, we can specify which storage account the VM data needs to be replicated to. And most importantly, we can also select the storage account. I'll explain later why it's important. And last, we can also map into an existing production network. So when you move your workloads across, if you have hybrid connectivity, either through a VPN or either through an express route, you will have your virtual machine communicating back to your on-premises environment. So I've selected all of that. And next what happens is my configuration server does a discovery by talking to the vCenter environment. So it lists all of the virtual machines that are available, which are not already protected. So these are the ones that are not protected. So I'm just going to go ahead and select VM5. So one of the other things that I want to showcase in here is we also have the capability to select which disks need to be replicated. Maybe you have a VM with temporary data, maybe it's a VM with some backup storage, which you actually don't need when you migrate up into Azure. So this capability allows us to select which disks needs to be migrated. Obviously, the operating system needs to be moved across, so it is selected by default. But if I don't need my E drive, I can untick my E drive. And also in here, I select an account, which is the account that's going to be used by the mobility service agent for an automatic push deployment, which will deploy the agent automatically on the VM. So once I've done all of that, what I need to do is I hit OK. And then I can select what is my replication policy. So at the moment, I've set my RPO to be 15 minutes. I've selected my retention for my recovery points to be 24 hours. So one recovery point is kept for 24 hours. And also every 60 minutes, we have app consistent snapshot. With the capability of having the mobility agent inside the VM, we can now do app consistent snapshots. Another capability that I want to look at in here is the multiple VM consistency. So most of the time, you would have applications that are multi-tiered, whether it's 2-tiered, 3-tiered. What this allows us to do is, when we take these application consistent snapshots or crash consistent snapshots, if you've added them to a replication group, the snapshots will be taken at the same time, which means if you do a restore, which means if you go back to a different recovery point, there won't be any inconsistencies with the snapshots. If you had selected 4 virtual machines, all of the 4 virtual machines will be, it will take snapshots at the same time. So that gives us flexibility to group these applications together, group these virtual machines together when we plan for migration or when we plan for disaster recovery. So I'm not going to hit OK. What I will do, I'm just quickly going to show what I've recorded before on how that replication looks like. So we've selected the VM, we've selected all of the options. And what will happen once you hit enable replication, it is then going to install the mobility service agent. So if you don't have the agent deployed, it will automatically install the agent. And also in the backend, what's going to happen is that it's going to run through these phases. So one of the things is that once the replication gets completed, it will then start shipping data into my Azure Site Recovery Vault. So this is something to be mindful of when you start your replication. We need to essentially identify and plan for our bandwidth. So in this example, I'm just going to skip forward. In this example, in my environment, I have a 30 meg pipe for my upload. And since I haven't done any bandwidth throttling, you would see that it's taking the entire bandwidth available. And you can see that when I go into my network properties, it's actually shipping all of that data into a blob storage. So if I quickly zoom in on that, you will notice in here, this is actually a blob storage URL where we are moving that data across. So the data does not get write direct to a VM. As I mentioned before, it gets written to a blob storage. So this is how we enable virtual machines. So if you have 10 virtual machines, you can enable protection for those virtual machines, which will then kick off that replication process. So we've done that. So what I want to cover next is around the requirements. So what are the requirements from a hypervisor? We support VMware ESX version 5.1 upwards. For Hyper-V, we support for 2012 R2 and upwards, obviously 16 as well. From a VMM System Center, we support for both 2012 R2 and 2016 as well. And in terms of planning and in terms of capacity management, one of the key things that you need to look at is running through the capacity planner. So this is one of the main challenges that I have seen from deployments that we've done. Unless you run through this capacity exercise with your customers, you will have you won't be able to set proper expectations in terms of when the virtual machines are going to get across. Because with this capacity planner workbook, it's an Excel workbook that you can download. What we provide is we provide the average number of VMs. So that's an input that you put in. We need to also provide the average number of size for your virtual machines. So you can gather some of this information from the Microsoft assessment and planning toolkit. And then the last thing that you need to input is the rate of changes. So rate of changes is a tricky one for us to get. And the best way to do it at the moment is to work with your backup administrators, to talk to your backup team, to understand, looking at differential backups, how much data have we changed. So if you know the rate of changes, you can put that in as well. And the output that you get, most importantly, first thing is that the bandwidth estimate. How much bandwidth do we need to replicate these VMs up into Azure? Second, in Azure, what are the resources you need? Can we use one storage account and fit all of the VMs? Or do we need multiple storage accounts? Anyone knows the limit of I/O for a storage account? So for a storage account, we have a limit of 20,000 I/O. So if you have 200 virtual machines, you start moving all of those across to a single storage account, you would easily hit the 20,000 I/O limit. So when you run through this bandwidth assessment, as you can see, line number 3, you would see it says storage accounts required equals to 3. So you need to spread that workload across at least 3 storage accounts for you to have optimum performance. And then another item is that it also shows how many process servers I need to have. So if I'm migrating 400 virtual machines, or if I'm migrating 500 virtual machines, this would ideally come up and say you need to have maybe 2 or 3 process servers, depending on the number of available bandwidth and depending on the available number of virtual machines that we need to move across. So this workbook is an essential component when you want to plan for your either the migration or disaster recovery. One of the other things that we need to plan for, as I mentioned before, is how you manage your available bandwidth. Because Azure Site Recovery writes into a blob storage, if you have ExpressRoute with private peering, it would not use your private peering path to replicate that data. So if you have a VPN or if you are using internet, then the bandwidth, then the replication will use your internet pipe across. So how do we throttle this? So within Azure Site Recovery, we can set a schedule to say within office hours, so 9 a.m. to 5 p.m., starting on Monday till Friday, I'm only allowing 10 megs of data to be migrated. So I can set these throttling settings so that my link will not get saturated. So I will not overload my internet bandwidth, making sure that my users can also work. I can set these settings. And it is recommended that we set them. The reason is that when you start migrating across, it's going to take the maximum bandwidth available in your internet pipe. Another item for consideration for networking specifically, unless it's a real small environment, when you migrate your workload into Azure, you would have a hybrid connectivity, which means that you would have an IP addressing scheme on premises in your data center. You would also have an IP address scheme up in Azure. And these two addresses are not overlapping. So it's a separate address scheme that we have up in Azure. Which means that when I move my workload into Azure, and when I start my virtual machines, the IP addressing will change. So if you do have legacy applications which are dependent on IP addressing, those applications need to be remediated. Because you move it across, you would not have the same IP addressing. Unless it's a small environment where you can migrate all of the VMs in one go, and then you would have the same IP addresses configured up in Azure. Another capability using some of the other Azure services, such as Traffic Manager, if you have externally published websites, you can use Azure Traffic Manager so that when you migrate your workload across to Azure, you don't need to go in and update your external DNS entries. You redirect all of that traffic into Traffic Manager well before you do your migration. And then the Traffic Manager can be configured as a failover option. So it will only redirect traffic to my VMware environment, my on-premises data center. And then once I migrate them across, once I've finished the migration, I would inform Traffic Manager to say, don't send the traffic into my on-premises environment, send it up to Azure. So I can do that change fairly quickly using Azure Traffic Manager instead of me going in and updating my public DNS entries. Another option that we have in terms of network connectivity is to enable public peering. So when you look at your private peering, so what private peering provides is it exposes your private endpoints in your VMs, your private IP addressing gets exposed through a private circuit into your Azure, into your on-premises data center. But when we look at Azure storage, when we look at Azure SQL as an example, these are all public services which are actually using public IP addressing. When you enable public peering, what it does is it exposes those public IP addressing into your environment through your express route. So what's the benefit we have by enabling this? Instead of using your internet bandwidth to do your virtual machine replication, you can now take advantage of express route, and you can have the storage traffic sent through your express route. But this requires you to enable your public peering. Usually what we've seen is with customers, when they want to look at from a DR scenario, this is what makes sense. But if you are doing a migration, it's a one-time migration that you want to move across. Most customers prefer to temporarily increase the bandwidth. They would get a 500 meg link, temporarily increase the bandwidth, move all of that workload that they want to move across to Azure, and then they can reduce the bandwidth as required. So next what I'm going to do is, now we've started replicating across. We started replicating some applications into Azure. So next, let's go ahead and have a look. Once it's replicated, how do we test? What are the options we have to test those workloads into Azure without impacting anything that I'm running in production? So what I'm going to do, I'm going to open up my Azure environment. I'm going to go into my recovery vault. And what you would see in here under my replicated applications, there is 3 virtual machines that says waiting for input. The reason why it says it's waiting for input is that I've already done a test failover for these applications. So once you initiate a test failover, you can select a test VNet, which is isolated from your environment. And then you can have like a jump box for you to log in. You then test the application. So let me show you how that process works. So I'm going to select virtual machine 4, and then I'm going to click on test failover. So when I click on test failover, as I mentioned before, it will provide me options where I can first select the recovery point. So if I want to go for a previous recovery point, so example, if I click custom, this will now show me all of the recovery points that I've had since I started my replication yesterday. So I have multiple options if I want to go either a crash consistent recovery point or either an application consistent recovery point. So I have multiple options. For now, I'm going to use the latest recovery point available, and then it's going to show me what are the available networks. So only one of my networks is connected to my environment. All the other networks are isolated. So I'm going to go ahead and select a network which I will use for testing. So I'm going to select test failover VNet. And then once I hit OK, what it's going to do is it's then going to create a virtual machine, and it will provide the test environment for me. So I've already done that for the 3 virtual machines. And one of the things you can also do when you have multiple virtual machines. So I've just demonstrated how you would do it for a single VM. But ideally, in an enterprise environment, you would have more than one. So you don't have to manually go into each VM and run through this process. What you then do is you create something called a recovery plan. So a recovery plan, if you look at in here, what it allows me to do is it allows me to add virtual machines into a plan. And then what I can do is I can do a test failover for the entire plan, which will then create a test environment based on the sequence that I've specified. My Active Directory environment will come up first. My database environment will come up next. My application tier will come up third. And then last, my web tier will come up. So I can sequence how that needs to happen. And one of the other capabilities that I want to showcase is the cleanup test failover. So if you have done your testing, you've already done all of the DR testing or migration testing that you want to do. Now, if you click on the test, cleanup test failover, what it's going to do is it will automatically delete the test environment and clean up your test environment for you, completely automated. So I'm quickly going to do that. Before, I'm just going to show my virtual machine environment. It's just going to go into VMs. And what you would notice is that the 3 VMs that I've selected and my domain controller, they all have test next to them, which means that these are the resources that were created, part of my test failover. And you can also see there's another VM getting created. This is the one which we just initiated, the one that's creating a temporary VM, and it will then have the virtual machine data moved across, and it will create me my test virtual machine. So once you've done your test, once you have created the VMs, you can have a public IP address, and then you can log in to that virtual machine, which I have open up in here already. And you can go in and do all of the testing that you want. So in here, I have a SharePoint application. So I've done all of the testing that I want. I confirm that the application is working as expected. So now what I can do is I can go ahead and I can clean up this test environment because I've already verified that it's working. So I'm just going to go back. Going to go into the recovery vault. And then I will initiate a test failover. Initiate the cleanup for my test failover. So it's going to go into the recovery plan. And then I'm going to say, I've done my testing. Please clean it up. So when you clean up, it says, yep, clean up. And also gives you this option. Testing complete, delete the test VM. So this is something you need to click. Otherwise, what will happen is that the process gets completed, but you will still have your virtual machines running. There could also be scenarios where you would want them. One of the recent projects that we did, a customer wanted multiple replicas of a production application. So when developers want to develop something new, what they would do is they would do a test failover. They will have an entire replica of your production environment in a complete different test environment. And then what they will do is, because this environment needs to run for a number of days, they will say testing is completed and leave the virtual machines up and running. So this allows you to replicate and have a test environment spin up available for your developers for them to go ahead and do any of the testing that they want to do. So I'm going to say testing completed, and I'm going to select this option, and then I'm going to hit OK, which will go ahead and clean up the test environment. So it will delete the virtual machines. It will delete any of the resources that I've used. All of that gets cleaned up. So we've looked at how we will be doing testing. So now what we will be doing next is look at what are the common challenges that we have. So one of the common challenges that we faced, especially when we want to migrate or even protect for DR, is the limitation in Azure for disk, for virtual disks. So at the moment, only up to 1 terabyte of disks are supported. So a couple of engagements that we had, we came across some legacy data warehouses running on SQL. DFS servers, file servers, which are having 3 terabytes, 5 terabytes of data. So we will look at how we can mitigate some of these challenges. One of the other things that I've covered already is around the bandwidth planning. So it's essential that you look at the bandwidth planning workbook for you to cover how much bandwidth you need, how many storage accounts you need, and also to cover number of process servers that you need. So this also relates to your virtual machine performance. You need to be able to properly segregate your virtual machines so they would have their own storage accounts. They would not run on the same storage accounts, which provides negative performance. So these are some of the things that needs to be looked at when you want to migrate your virtual machines across. So with the 1 terabyte limitation that we have, how do we mitigate or how do we solve this? So if it's a 2012 server, you can create multiple VMDK files or multiple VHD files less than 1 terabyte. You can present them to the operating system and you can create a storage space. If it's not running 2012, if it's running, let's say it's running an older version of Windows 2008 R2, you can then create as a striped volume. So creating the volume is really the easy part, but the difficult part is where you need to do a migration from your existing volume to the new volume that you've created. So we've successfully used Robocopy to do that, which replicates not just your data, but also replicates folder permissions as well. So you can use Robocopy with parameters to replicate that data across. And then what you would do is you would remove your volume, and you would add the same drive letter that you had on your previous volume to the new storage space that you've created. So that's how you would solve the issue around 1 terabyte storage. UEFI is also not supported to run in Azure. So if you have Hyper-V environments running Gen 2 VMs, you don't need to do anything on your own. They automatically get converted to Gen 1 when they get moved across to Azure. We need to also deploy the mobility service agent. So the agent can be automatically deployed. If you have an administrative account that you want to put in, we can automatically push the mobility client. Or you can leverage your existing deployment tools, such as Configuration Manager. Or you can also leverage PowerShell DSC to install the mobility service agent. So this is the agent that talks back to the process server, which informs all of the read-writes that's taking place in memory. Another common challenge that we faced is, again, with SQL clusters, legacy SQL clusters using shared storage. So Azure at the moment doesn't support shared storage for SQL clusters. So if you are running, if you have a customer or you are running SQL clusters using a shared drive, that needs to be migrated as well. So with most of the projects, you would find that there are certain applications that would not support or leverages a shared disk, which needs to be remediated. So in the case of a SQL server or a SQL cluster, the way to remediate that would be you spin up a new always on availability group cluster, and then you would migrate your databases across. So these are some of the challenges that you would have when you start your planning phase, when you start your planning to migrate your workloads up to Azure. And also another important aspect that I want to cover off is what do we use in which scenarios? If you look at certain applications like Exchange, like SQL, Active Directory, these applications, they have their own way of doing disaster recovery, their own application-aware application. So the preference for site recovery, if the application can do replication on its own, if the application can do disaster recovery on its own, you would rely on the application to do that replication. So with SQL always on availability groups as an example, I would have 2 instances in my on-premises environment, and then I will create a stretch cluster across. I would have 3rd and the 4th node spin up in Azure, and I would have that data replicated, not using ASR, not using site recovery, but I would leverage SQL to do the replication. But if the application cannot do replication on its own, then you would use Azure Site Recovery, which will then migrate the entire operating system instance up into Azure. Another key component in here is you need to be able to have an Active Directory environment, both in your Azure environment as well as in your on-premises environment. Why is this required? Let's say if you are using ExpressRoute, or let's say for some reason you are using a VPN, a site-to-site VPN, an IPsec tunnel. For some reason, if this channel breaks and you don't have a domain control up in Azure, for some reason your VPN gets disconnected. So all of the virtual machines now that are running in your Azure environment, they cannot authenticate. They don't have a service to authenticate against. And any service that's client-facing would not be able to authenticate the users across. So that's why, as a recommendation, we need to do an Active Directory extension where we create a new site. We add the Azure IP subnets into Active Directory, and then we will create a new domain control up in Azure. There was a recent announcement where we can now, Azure supports single instance SLAs for virtual machines, provided that they run in solid state storage. So as long as you use SSD storage, so as a start, when you start migrating across, you can start with a single Active Directory instance on a solid state virtual machine, which will also be covered for the SLA as well for the virtual machine. And also it will provide you with great availability when you start migrating your workloads up into Azure. So now what we will be doing is, we've already looked at how we do some of the preparation for us to migrate into Azure. We've enabled protection. We've also done a test failover. Now what I'm going to do is I'm actually going to show you how the failover process works when you say not a test failover, but when you select the unplanned failover option, what actually happens. So let's go into a demonstration. And in this demo, what I'll be showing is how we can move our replicated virtual machine. So in this example in here, we would have a couple of virtual machines that are replicated already. So these virtual machines, as you can see, they are already protected, which means that I can now fail these virtual machines across. So I'm going to select one of the virtual machines. Or in fact, what I can do is I can select the recovery plan, which will in one go replicate, one go cut over both of the virtual machines across. So I'm going to use this option called unplanned failover for me to do the cutover. So I've done all of the testing, I've done all of the planning that I need to do. Now I'm ready to have these virtual machines running in Azure. So I'm just going to do that, select unplanned failover. And then what I'm going to do is I'm going to say I need the latest recovery point. So the direction available in here is from my process server into Azure. So that's the correct direction. The reason why we have the direction, if you look at, if you have two data centers on premises, you can also change the direction as well. So if you want to move, let's say for some reason there's some corruption, you want to move from your DR into your production, you can also do it. So you can change your replication direction. So I've selected my RPO that I want to use, the latest RPO, and then I'm also going to select the option where it allows me to shut down these virtual machines. And then once I click OK, what's going to happen is that Azure Site Recovery talks back to my management server. Management server will then start triggering the failover process. So part of the failover process, what it will also do is it will talk to my vCenter environment, my VMware environment, and it will start shutting down these virtual machines. So we've just kicked off that process. So when you kick off a process within Azure Site Recovery, you can go into Site Recovery Jobs, which actually shows current jobs in progress, and also it shows the jobs that are having issues or failed jobs. So I'm just going to go in and see what is the current status. Just going to go back to the overview. So if you look at the moment, there is one job that is a failover job. And when I go in, you can see that it's already created the environment. Now what it's doing the shutdown process. So the VMs can be grouped as well, which I will demonstrate in a bit, where you can sequence the virtual machines in terms of the order that you want them to come up. So when you look at shutting down the VMs, if I now go back to my process server, to my vCenter environment, you will notice in a bit these virtual machines will automatically start shutting down. So that's orchestrated part of the DR process or part of the migration process. The virtual machine environment, the virtual machines that I've selected part of that migration batch gets moved across. Another important item that I want to highlight in here is that once you've done the migration, once you've done the cutover, so you can just see that it was just turned off. Once you've done your cutover, you need to make sure that you start renaming your virtual machines, which I've done, which I'll be doing now, because once you've completed the migration, what happens is the VMs get removed from the recovery vault, and if you have multiple resources working on your environment, they wouldn't know whether this VM was migrated or not. They might actually go in and start these VMs. So what happens if they start the VM? You now have an identical VM running in your VMware environment, and it's running in Azure as well, which would create a naming conflict. So it is not ideal. So we want to make sure that once you've done your migrations, you would go in and you would rename, and you would say this is already migrated. So one of the other things that I want to show is, let's look at the migration process. So it's still running through the migration. So what I'm going to do is I'm going to quickly switch into a recording which I did just before. And in this recording, what we will look at is once you've completed the migration, you have an option where you can go in and you can complete the migration. So what is the benefit of the complete migrate option, so which is in here? So this complete migration option does two things. One is that it will remove the content from the recovery vault, and also it will inform my process server on premises that the virtual machine has been migrated. So it cleans the environment. So if you look at, once I click on complete migration, it says that it gives me a warning to say that this is going to be removed from the vault. Do you agree? And then once you click OK, it runs through the job process. It will invoke a job. It will then go ahead, and what will happen in a bit, if you do a refresh, you would notice that that virtual machine is no more. So you're looking at VM4. So once the job completes, if you go ahead and refresh again, which I'll be doing in a second, you would notice that the virtual machine is no longer available in the vault. The VM's gone from the vault, but the virtual machine is available in my virtual machines area. So if I go into my virtual machines, you would see that VM4 is up and running. It has received an IP address from my virtual network connected to my express route. So now I have connectivity for that virtual machine as well. So that's really the last step that you would want to do when you want to migrate across. You select your failover, do an unplanned failover. You go in, you do the testing that you want to do. So you test and see if it works. And then as the final step, you click on complete migration, which will then clean up your recovery vault and have the virtual machine running up and running in Azure. So now that we've looked at how this works for a bunch of virtual machines, let's look at how we can do some ongoing monitoring and also a bit of management. Because your migration is not going to be one VM, it's not going to be 4 VMs. Ideally, it could be a number of batches. So sequentially, when you start migrating these batches across, you need to be able to understand any errors in the environment or any warnings that are in the environment. So the first thing is that when you go into your protected items section, you would notice a health status. So the health status provides you a visual indication to immediately know if there are any errors, if there are any issues within the replication. So this could be due to insufficient bandwidth. It could be due to a failure in the process server. Maybe the process server got restarted accidentally, or someone restarted the process server, so the replication isn't passing through anymore. So this gives us indication in terms of knowing what are the errors, and also what are the probable causes and the recommendations for an error. So this is essentially visually looking at what's going on using the Azure portal, but that's not going to be enough because we are not going to be logged into the Azure portal all the time. So you still need to be able to receive some notifications if something fails. So within Azure Site Recovery, we have a email notification events section where you can go ahead and you can enable email notifications. So without any dependency to your Exchange environments or your Office 365 environment, Azure as a service will send these emails across. So you can set it to either email your administrators, or you can provide an email address. Maybe it's a specific mailbox you've created for a migration project. You can put that in. You can put your own personal email address, your corporate email address that you use. So in that, any event that fails, anything that is failing, you would then get a notification directly onto your inbox. So this is also important when you start your migrating batches across, that you have an understanding on things that are failing, or you have an understanding on if there are any issues occurring in the environment. Also, when we go into the Azure Site Recovery Vault, it also shows us if there are any events for the last 24 hours that failed. And also, another important item is if there are any updates available. So if you look at in here in the screenshot, it says updates available. The reason why it says updates available is that Azure Site Recovery provider gets updated frequently. So if there's an updated provider, you can essentially go in and do this. So this is, again, not so much for migrations, but if you are doing disaster recovery, then you would want to make sure that the agents are at an updated level. When you have the latest provider, you would want to go ahead and update that environment. So health status provides us with information around if there are any failed jobs in the environment. So if I quickly jump back into my environment, you would notice that there were a couple of jobs that failed. So I can go into the environment and quickly at a glance know there are 14 jobs that failed in the last 24 hours. So I can quickly go in and have a look at to understand what are the jobs that failed. So this essentially works as an information hub to know what kind of snapshots which were taken. So not just the errors that we have, not just the warnings, but acts more like an event log for us to understand what are the events taking place in the environment. So we've looked at migrating batches up into Azure. We've looked at how we can look at some of the ongoing monitoring, how we can get some of the ongoing management. So the next capability that I will be talking about is once you've done your monitoring and once you have your batches across to Azure, let's say I've got 100 VMs and I migrate all of them up into Azure. So now you want to further protect your virtual machines. All of my workloads are running in Melbourne data center, for an example. I want to make sure that if something happens to the Melbourne data center, if something happens to, maybe it's a storage failure, a partial storage failure affecting some of my virtual machines, maybe it's a partial network outage affecting some of my virtual machines, I need to make sure that I have the power, I have the capability for me to go in and do a migration and run my virtual machines in Sydney, which is not affected by the network or the storage outage. So in preview, we have a capability called Azure to Azure DR, or protecting IaaS workloads using Azure Site Recovery. So what this allows us to do is it allows us to replicate virtual machines from Melbourne. So if you have your virtual machines in Melbourne, we can replicate to Sydney data center. So likewise, when you can select a data center that you want. So at the moment, they are in pairs. So applications that I have in Sydney, I can replicate into Melbourne. And the applications that I have in Melbourne, I can replicate back into Sydney. And this is completely integrated into Azure Site Recovery. So my recovery plans that I've created, the scripts that I would run from Azure Automation, all of that integrates into enabling these DR capabilities. So how does it work? So in this example that I will demonstrate, I have a couple of virtual machines running in my Southeast data center, which is the Melbourne data center. I have 2 virtual machines. And if you look at, we have a network resource, we have network adapter resources, we also have a storage resource. So when I enable protection, so when I go in and enable protection for this environment, what Azure Site Recovery would do, it would then go ahead and automatically create these resources. It will create a virtual network. If I haven't created already, it will automatically create one for me. It will create these network resources that I want. It will also create a storage account. Another item that gets installed on your virtual machine is that there is an agent that gets deployed. So this is the same mobility agent that gets deployed, but we can install it as an extension. So we don't need to provide any account for us to do this deployment. It uses the Azure agent that you have on your virtual machines, migrated into Azure. And when we enable this replication, it will automatically go in and use VM extensions to go in and install the site recovery agent. So once the agent gets deployed, we now know about all of the read writes that's happening in memory. We also know about the data that's already committed into the Hyper-V or the hypervisor environment. So we then can do a failover. And then once we do the failover, what happens is that the VM gets connected to the storage, VM gets connected to the adapters that we've created, and the VM gets connected to the VNet that I specified. So let's go into a quick demonstration, and let's see, once we've done the migration across to Azure, how you can actually further protect your workloads from an Azure data center. So in this example, I'm going to show some of the applications that I have in Melbourne data center. So going into Azure Site Recovery Vault, I'm going to go into Azure Melbourne Vault that I've created. And then if I go into replicated items, what you'd notice is that I have 2 virtual machines protected. And the difference is that the current active location, if you look at, the current active location is Australia East, which means these virtual machines are running in the Sydney data center, in the Melbourne data center. And also, if I want to add a few other virtual machines, I can just, similar to what I did before, I can go in, and the difference in here is that instead of selecting on-premises as the source, in here what I will be doing is I'll be selecting Azure as my source, because the virtual machines are now up and running in Azure. So what I'm going to do now, I'm going to select Azure as my source. I'm going to select the source location, which is in Sydney. I'm going to select which deployment model, whether it's resource manager or classic virtual machines. And then I'm going to select the resource group where I have my virtual machines running at the moment. So I've selected a resource group. I'm going to click next. What this is going to do next is it discovers all of the VMs in that particular resource group. So right now I only have one VM. You also have a search function here. So if you have virtual machines with tags, you can also search by tags as well. So it gives you a way of quickly finding the virtual machines that you want to protect. So I'm going to just select this VM. So what's going to happen next is that you will notice it gives me with multiple options. So few options in here, it talks about what is the target resource group. So this is a new resource group that gets created. Also talks about the target VNet. So this is an existing production VNet that I have. But if I want to have a different VNet connected, I can click the customize option, which allows me to select an existing storage account for caching. Also for the target storage, I can select an existing storage account. Also for my networking, I can go in and I can select a different resource group as well. If I want the VMs to be replicated to a different resource group, I can also do that. So it's showing me at the moment all of the available resource groups in my Melbourne data center. So once I've selected all of that, I can also select, what is the retention policy? What kind of data retention do I need in terms of my recovery points? You can set all of that. And then what you do is you then click on create target resources, which will automatically go in and create my storage accounts, all of the resources that we talked about before in the architecture. All of that gets automatically created. So it's submitting that job. So once you have these resources created, what happens is you would have these virtual machines. The virtual machine will be visible in your replicated items, and it will say synchronization in progress. So at the moment, these two virtual machines, they are replicated already. So now if I select one of these virtual machines, and if I scroll down, it actually shows me from where it's replicating. So if you look at this diagram in here, which shows that the VMs are replicating from Melbourne data center into my Sydney data center. So I've created the replication already, and similar to what we looked at before, even with Azure to Azure DR, we can still do our test failover. So if I want to go ahead and do a test failover, I can still do that. If I want to invoke a failover, I can also do a failover as well into the Sydney data center. So I have all of those options available. And when you click failover, if you haven't done any testing, one of the pop-ups that you would see now is that it says that you haven't done any testing for the past 60 days. Are you sure that this config would work? So it just gives you a visual warning to say that you haven't actually tested this application for the last 60 days. So you would say, yep, that's fine. I'm going to understand the risk. Click shut down the virtual machine. And then once you submit this job, what happens is that the virtual machines gets moved from your Melbourne data center into the Sydney data center. So for the interest of time, I've also captured how that process works. So I'm just going to quickly show. First, we are going to quickly look at enabling protection. So we've kind of covered that as well. We can go into the virtual machine. We create a vault, just similar to what we've created before when we create our resources. So we create an Azure Site Recovery Vault. We go in, we hit replication. You select the source and the destination resources that you want. And then you would go ahead and hit submit, which initiates the replication process. So once the replication process gets kicked in, what you would notice is that you would have these resources. So this is the Azure Site Recovery Agent that I was speaking about before, which initiates the replication from your existing data center into the second Azure data center. So with that, I'm also going to talk about if you have a complex application with multiple tiers, how does it work with the current solution? So if you have this application as an example where we have external load balancers, we have a public IP address, we have internal load balancers. When we protect this using Azure Site Recovery into a second Azure data center, we can go ahead and create these resources beforehand. So you would have the load balancers provisioned for you. You would have the storage accounts provisioned for you. And then you would have a caching storage account, which is to cache all of the data reads and data writes. And then once you invoke your failover, what happens is that these virtual machines will come in and get plugged into these resources which we've created already. So this is essentially an easier failover approach for you. You don't need to worry about all of the dependent resources that you have. We have these resources created, and then you would be able to seamlessly run your application. If it's an external application like the one we have in here, you can also use Traffic Manager, which will also do the failover for your external client request coming in, failover automatically to Sydney, and the workloads will run in the Sydney environment. So what I will do, let me quickly show you how that actually looks like. So going into a quick demonstration. So in here what we have is, once we protected these environments, we can go ahead and we can invoke a failover. So in here I have two virtual machines. So one by one I'm going to invoke failover. So before I do the failover, I'm just verifying all of the settings, making sure that it is connected to the correct network. It is having the correct VM specification. So I'm verifying all of that. And once I've done that, what I can do is I can go ahead and click the failover button. So similar to what we looked at before, you click on failover, which will go ahead and enable that failover option. And what we will see part of the failover is that the virtual machine gets stopped. And moving into the VM section, so you would see that it does all of the checks similar to the VMware environment. And then when you go into the virtual machine section, so once you've done the failover, you would notice in here you actually have two sets of virtual machines with the same name. But one set would be stopped, deallocated, which are the ones that were turned off. And then you would have another set that is actually running, which are the virtual machines running in my target data center environment. So once you've done that, you can also complete the failover, which will then remove those resources that you have in the source environment. And once you have your source environment ready, you can then go ahead and start a reverse replication into your source environment. So this is just an example to show the virtual machine is up and running. And also going into the virtual machine, it's also taken different IP addressing and also different DNS settings based on what you've specified in the VNet in your Sydney site. So all of those configuration gets automatically applied when the virtual machine comes up. And you can also access the application, and the application will also expect to work without having any trouble if you've done your failover testing before. So one of the important things to consider when you do DR, if you want to move workloads from one data center to the other, you need to make sure that from your office, from your on-premises environment, there is connectivity to both data centers. So if you only had connectivity to Sydney data center, you fail over to your Melbourne environment, none of the users in your office will be able to reach to those virtual machines unless those are external facing virtual machines like a SharePoint site, which has been published. So it's important that you have either a VPN tunnel or an MPLS cloud with ExpressRoute connected so that you can switch from one data center to another and have your application still connected. So one of the other things, additional component that I want to talk about, part of our failover, part of our migration, and even if it's DR, you can also use Azure Automation. So Azure Automation has something called Azure Automation Context, which we can use part of our recovery plans, and we can automatically invoke a runbook, a PowerShell script, which will go and make some modification on my virtual machines. So let me quickly go into another demonstration and show how that looks like. So if I go into my portal, and if I go into my recovery plans that I've created, so I'm just going to go into my VMM01 Vault. I'm going to go into a recovery plan, and then I'm going to click on a recovery plan which I created before. So in this recovery plan, if I click on Customize, what you would notice is that I actually have 3 different groups. So when I invoke this recovery plan, it's not going to bring all of these virtual machines at the same time. It will follow this sequence which are specified. So what's the sequence? First, the group 1 virtual machines come up. Second, group 2, the virtual machine in group 2 comes up. And also another step that I'm doing after these virtual machines comes up, after having these virtual machines running, what will happen is that I'm going to run a script. So this script, I'm not running it from a virtual machine. What I'm doing in here is I'm selecting scripts available part of my Azure automation. So if I say update script, what it's going to do is it's going to show my Azure automation account. And I've used this, which opens up RDP. Because you might have virtual machines on premises which doesn't have RDP enabled. Or maybe it's a firewall setting that you want to reset so that you can connect to those virtual machines. So there are a number of scripts available. Maybe it's a port that you want to open. You can select a script that you want, and then part of executing your recovery plan, Azure automation will kick in automatically and go ahead and modify those settings, modify those changes that you want in your virtual machine environment. So with that, I want to summarize what we've looked at. So we've looked at how we plan for disaster recovery, how we plan for migration. We've looked at how we can do a test failover, both from an Azure to Azure protection, and also from an on-premise to Azure environment. We've also looked at how we can migrate them across. So once you migrate, how you can complete the migration. We've looked at some of that. We've looked at how you can do your ongoing monitoring. And further, we've also looked at once the virtual machines are up in Azure, how you can go ahead and further protect them by replicating them to a second geographical location. So with that, I'm going to summarize my session, and I'm going to have a couple of slides available which have some reference points. Also, you can download this deck. All of the demonstrations that I've showed, I've used Camtasia and captured all of them, so you can go ahead and have a look at some of those demonstrations. So the slide deck itself will be about 100 and 150 megs in size, but feel free to go ahead and download and have a look. Please complete the evaluation, provide feedback to the Ignite organizing committee. Collect your wristbands for Spark After Dark. And I'm going to be at the speakers lounge, or I'm going to be at the MVP lounge. So feel free to come in and have a chat. You could also follow me in Twitter as well. I'm going to be here for the next 10 to 15 minutes. So if you have any questions, feel free to reach out. Thank you so much for your time. Thank you for attending.